Okay, then so this is what I'll write it F minimum. So now n minus F minimum equals 0. The friction should balance mg. This equal to mu n. So what is F minimum? Mg by mu. If you apply force greater than this, equilibrium is possible. Sir, now I'll do one thing, sir. I'll apply force. I'll keep on increase force. Block will then at one point, if I keep on increase F minimum, n will increase. Then as n increases, then at one point friction can it become greater than weight? Not possible. Huh? It can never happen. If you want to try it, how much all hard you press the book against the wall, the book will not slide up. But as you keep on decrease force at one particular value, it starts sliding down. The reason, because the applied force is less than mg by mu. Hey, Pranav, I'm muting it again. You are unmuting, huh? Applied force greater than mg by mu block will be at rest. Mg by mu block slides down.
Sir,
Yeah.
if the surface is smooth, it can never be in equilibrium, no, sir?
Yeah, never, not possible. Huh?
Okay, sir.
Okay, if they're smooth, I think not possible. No, how much all hard you try it or what all force you apply it, it can never be in equilibrium. But smooth surface not possible. And now we can apply the forces in different ways here. Can we apply the same force at an angle? Here only will bring. Now the similar situation, I'll apply the force at an angle. So the force is applied at an angle. Then what are the range of forces for which block will be in equilibrium? Find the value of force F. There's a condition. So we'll resolve this force along x, along y, then we'll see what conditions will get it. Huh? So if I resolve it, here only once again, I'll resolve it. F cos theta, F sin theta, n minus F cos theta 0. The frictional force will be acting upward. I assumed it. F plus F cos theta minus mg equal to 0.
Sin theta.
Sin theta. F equal to mu n equal to F cos theta. Now let me keep on apply the force. Shall I call this a minimum or maximum? This will be minimum. Huh? because the block is about to slide down. Okay, this will become minimum. Let me keep on increase the applied force. Then at one instant,
Block will slide up.
the block will about to slide up, the friction will act downward.
Yes.
This is what I think. You can try all these things. I'm telling this one rather than you troubling me, you trouble yourself. Take one book or blog, something. Try to push it normal to the wall. Try to push it at an angle with respect to wall. See all these conditions. You can, what all you're studying, no, you can realize. Then you'll get exact clarity. Confidence will come. Why? See, why I am very confident on the screen? Because I know all these things. Why you are not confident? Because you are just teachers telling you are listening. So not possible. You have to realize all these things. So at least after class, no, you can, now you are sitting in home. Luckily you are very at night better position. So take some notebook and start pressing it against the wall and see that how you apply force. What is F here? The moment if I saw nothing but you are pushing, no, here. Is it a push or pull force? It's a push force, no? So try to push at an angle. Sir, how I should push means then I am not going to help you in this aspect. By this time you should know what you mean by push and pull force. We'll go for F max here now. So when the applied force is F max, then the conditions here will be, I need this. Yeah. Okay, some of you are making observation. I'll take the next condition. F max will go for it. So here how the same thing, the force is applied now, same push force. Now this will be F max, I should call. The block is having a tendency now to slide up. There's a friction on the wall. Again resolving all the forces. Let's write all the equations. N minus F cos theta equals 0, F sin theta minus F minus mg 0. You see, totally looking at equation, I can call it as F max. Now, shall we bring in some sort of range here? If the applied force is less than F minimum, the block will slide down. If the applied force greater than F max, the block will slide up. Then at one particular value of force F, the friction will be 0.
Sir,
Yeah.
sir, could you just tell that statement once again? You said if the applied force is greater.
It's there. No, don't you know mathematics, my dear? How beautifully you people are asking me. Huh? Don't you know maths? This minimum thing. You have diagrams, everything, and people are hunting for my words. The statements I'm telling, statement is not concept, just like what is there, no, that I'm concluding. So why don't you make such observations? I will repeat, but you should able to analyze, no. See, what is the conclusion of this equation, you are able to do it. say when f less than f minimum, the block will slide down. This I'll write it. This is what a student should conclude. This should not come from teacher, from student. This should come. If everything teacher does, then what is your role? Okay, if the applied force less than F minimum, block slide down. Applied force greater than F max, the block will slide up. Then any force between this range S, the block will be in equilibrium. I think how the forces are applied, you have to be very careful. I'll make all this observation. Will all of you have to analyze, not just mere looking, nothing will happen. Please do understand. Please try to understand. You have to analyze here. Analyze means what will happen to F if I make it greater than